Jesus Christ, man. Same thing again. All right, so my last line, let me draw my last line now. So my last line will be drawn using the points 0, 10. So talk about these points right here, 0, 10, 15, 0. So 0, 10 is right here, and 15, 0. Right? So I have my 4 lines, and now I must identify the region that is satisfying all 4 inequalities. Now, if you notice, if you go back here, the inequality we're dealing with here is 2x plus 3y is less than or equal to 30. So this line right here represents 2x plus 3y equals 30. So therefore, if you're interested in the region 2x plus 3y is less than or equal to 30, we're talking about on or below that line. So basically, our regions, or we want to shade and label the region that satisfies all 4 inequalities. All 4 inequalities involve, oh no, I lied. All right, so let's identify them once again. Oh, let me see. Oh, all right, I made a little mistake here. Um, x plus y is all right, so I made a little mistake here when I wrote down x plus y is less than or equal to 8. There should be x plus y is greater than or equal to 8. Right, so I have to change this now. So this should be this one as well. So y is greater than or equal to minus x plus 8. So this one should be on or above the line, above. Right. So all the others are below, but this one is above. So let's try to identify the region. We need to go below this black line, right? We need to go below this black line, so below this one. We need to go below the red line as well, so below the red line. We need to go below the orange line, but we need to go above the blue line. So can anybody see the region satisfying those requirements?
Yes, sir.
Tell me, all right. So if you can see the region, I want you to tell me one coordinate of the vertex of the region, or one of the corners. Tell me one of the coordinates which is on the region. I'm checking to see if you can really see the region, if you can identify it. So Renako, tell me the coordinates of one point that is at the corner of the region, or one of the vertices then.
Sir, x4, y4.
That is correct. Yes, that is one of them. So this is one right here. X equals 4, y equals 4. Kamari, do you see the region as well?
X4, Y4, sir.
Well, Ronaldo already told me that, but it's a region, so we have more points. If you're able to identify the region, tell me the coordinates of another vertex on the region. I'm going to call this one P. No, no, this is the region R, so I'm just call this A. Can you identify another point, Kamari?
Sir, that's below the yellow line, right?
Well, we can't just think about the yellow line alone, but I mean, below the yellow line, below the black line, below the red line, above the blue line. Can you
Um,
identify a point in this region? One
so
of the
you mean like
vertices.
the intercept of the lines?
Well, not necessarily, but yes and no. It's not always going to be an intersection of the lines, but there are other points which satisfy the region which are not the intersection of two lines. So can you identify any of the other points? Any of the other vertices?
X equals 6.
X6. And what is the Y value?
6.
Yes, this is another one. Right. Right. And of course, we're talking about this region down here. So again, we have to be below the red line, below the orange line, well, below the black line, and above the blue line. So we're talking about this region here. Right? That is our region. Okay?
Yes, sir.
Yes.
Mhm. All right. So part D. Having identified the region, says determine the two combinations for the minimum number of cars and vans that can be used to carry exactly 60 people on the tour. So usually to do that, we look at the vertices, the corners of the region. And let me check something here. So let's read off the coordinates. So this point right here, let's call it B. This one, of course, is 6, 6. We already identified this one as 4, 4. Right? Obviously, this one is 8, 0. And this one is 15, 0. So this says determine the two combinations for the minimum number of cars and minivans that can be used to carry exactly 60 people on the tour. Notice they say exactly 60 people. So if we go back to our initial inequality, which is 4x plus 6y equals 60. That inequality was 4x plus 6y equals 60, or we can say that 2x plus 3y equals 30. So basically what they want us to do, right, is to look at our region, and from the region, find the value of x and the value of y, which satisfies this inequality, 2x plus 3y equals 30. Now, let's check our points that we have identified. Let's check the point 4, 4. Two x plus 3y equals 30. So 2 times 4 plus 3 times 4 is that 30. We have 8 plus 12 equals 30. No, 20 is not equal to 30. So that means we rule out this point. You following?
Yes, sir.
Let's check
Yes,
the
sir.
next point. 6, 6. 2x plus 3y equals 30. 2 times 6 plus 3 times 6 equals 30. 12 plus 18 equals 30. 30 equals 30. So this meets our requirement. Okay? That meets our requirement. They want 2 combination. So from this, the obvious, let me see now. We have a point right here. Let me see this one here. Let's now for that combination, we must pay a lot of emphasis to the orange line and try to find a point on the orange line. Look at this one right here. This one right here passes through a corner. And this one, of course, is as coordinates 9, 4, 9, 4, right? So let's check that one. This one also passes through this point, which of course is 12, 2. We can check that one as well. But they want the minimum. So obviously 9 plus 4 is 13. 12 plus 2 is 14. So even if 12, 2 satisfies it, it will not be the minimum. Are you understand what I'm saying?
Sir.
They want us to find the minimum number of cars and vans that can carry exactly 60 people. In other words, the smallest combination of x and y that satisfies the equation 2x plus 3y equals 30. So we must look at the vertices as well as the other points through which these lines pass and see if they satisfy the equation. We already saw that 4, 4 does not satisfy it. We can't get 30 people using 4 cars and 4 minivans. However, if we have 6 cars and 6 minivans, that gives us 30 people. So we must check the other possibilities. Are you following?
Yes, sir.
Yes, sir.
Good. So let's check now to see. So if we check 9, 4, 2x plus 3y equals 30. So 2 times 9 plus 3 times 4 is equal to 30. We have 18 plus 12 is equal to 30. So 30 equals 30. So it does satisfy the condition, but is it minimum? Is it minimum?
Sir, I think so, sir.
So yes, I think that is the one. That is the one. 2x plus 3y equals 30. But we have, well, no, we have, yeah, that is the one that has the minimum. The only other one that satisfies the inequality is the point 15, 0. So when we check 15, 0, we know it's going to work. because this is going to be 2x plus 3y equals 30. So we have 2 times 15 plus 0 equals 30. 30 is equal to 30, but this obviously requires 15 cars, right? It requires 15 cars, and so that is not the minimum. So these are the two. This combination here, 9 cars and 4 minivans, 6 cars, 6 minivans, right? Yes, that is it. Okay?
Yes, sir.
All right, so the question's still not finished. The company charges $75 to rent a car and $90 to rent a minivan. Show that the minimum rental cost for this tour is $9.90. So look at the two combinations that we identified in D1 above. The two combinations are 6 cars, 6 minivans. And so our other one was the next one again? 9 cars, 4 minivans. So if we're renting 6 cars, 6 minivans, let's see the total cost. We're going to have 6 times 75 plus 6 times 90. 6 times 75, that gives us 450. And 6 times 90, that's 540. When we add those two, what do we get? 990. Everybody seeing that?
Yes, sir.
So this justifies our condition. Let's try the other combination now. 9 cars and 4 minivans. So we're going to have 9 times 75. I don't think this one is going to work though. 9 times 75 plus 4 times 90. What is 9 times 75? That is 750 minus 75. That is 675. 675 plus 360. So clearly this surpasses the 990. So this one will not be the minimum. You understand?
Yes,
So this
sir.
is actually going to be 960 plus 75. That's 1035. So of the two combinations, which are the minimum number of vehicles necessary, the minimum cost is 990, and that is when we use 6 minivans and 6 cars. All right? Is that
Yes,
clear?
sir.
Good.
Yes, sir.
Yes.
All right. So that was from that there. So yeah, these questions can be a little bit tedious, you understand? So that's why it's important that you do past paper questions as many as possible, so you get exposed to the exam type questions and how to approach them. All right. All right, let me see now. This one is from June 21, 2021. And let me see where it starts from. Right, so yeah. Right, so it starts there. All right, so let's look at this one now. Says the straight line graph of x equals 5 minus 3y intersects the x-axis at P and the y-axis at Q. Determine the coordinates of P and Q. So let's write down the equation. We have x equals 5 minus 3y. So let's try to illustrate what exactly we're shown here. So let this be our pair of x and y axes, right? Now this line, they tell us, intersects the x and y axis. Now let me just express in a slightly different form. X plus 3y is equal to 5. 3y is equal to minus x plus 5. So y is equal to minus a third x plus 5 over 3. I just did that to kind of get the shape of the line. So this is our y and this is our x. So the line shapes like that. So it clearly cuts the x-axis and the y-axis. we're told it intersects the x-axis at P. So this point right here is P, or this point is P, and this one right here is Q. Is that clear?
Yes, sir.
So Q is obviously the y-intercept. And as we established, at the y-intercept, x equals 0. So we can say that at Q, x equals 0. And so what this means is that y is equal to 0 plus 5 over 3. So y is equal to 5 over 3. So therefore, the coordinate of Q is the point 0, 5 over 3. Is that clear?
Yes,
Yes,
sir.
sir.
Similarly, when it cuts the x-axis at P, what value there is equal to 0? At P, what can you say about the point P? Hmm? What do we know? What do we know about point P? Is that on the x-axis? What does that tell us? Hmm? I said it before. What do we know about the
Y,
points? Yeah, go ahead.
um, tell us that y is 0.
Yes. At any point on the x-axis, y equals 0. So at P, y equals 0. So now we're going to set y equals 0 and solve for x. So we have the equation, of course, x equals 5 minus 3y, which means x is equal to 5 minus 0. So x is equal to 5. And therefore, P is the point 5, 0. You have to be able to interpret these things. Whenever a line or a curve intersects the x-axis, at that point, y equals 0. Wherever it intersects the y-axis, at that point, x equals 0. You have to remember those things, right? So the coordinates of P would be 5, 0, and that of Q would, of course, be 0, 5 over 3, right? So, yeah. So let's proceed. Jesus, why is that my freeze up the most? So once again, P is a point 5, 0, and Q is a point 0, 5 thirds. Right. Next part of the question says, calculate the length of PQ, giving your answer to 2 decimal places. So let's label the points. So P is the point 5, 0, and Q is the point 0, 5 over 3. All right, let me make some space here. So they want us to find the length of PQ. So as established, P is a point 5, 0, and Q is a point 0, 5, or 3. And this is basically asking us to find the length of the line. So you have to remember that if you have a point, or if you have a line joining the points, say A, which is say x1, y1, and B, which is x2, y2, then the length of AB is given by the square root of x2 minus x1 squared plus y2 minus y1 squared, right? I don't know if this is one of the formulas that is normally given at the front of the booklet, but you need to be able to use it and remember it too, just in case it's not given, right? The length of the line joining 2 points is given by that formula there. And so therefore the length of PQ, we can say that PQ, Jesus, sure. equals root of 5 minus 0 squared plus 0 minus 5 over 3 squared, which is equal to the root of 5 squared plus 5 over 3 squared, and you work that out, root of 25 plus 25 over 9, right? So what does that give us? 25 plus 25 over 9, that's root of 225 over 9 plus 25 over 9, which is the root of 250 over 9. Somebody work that out for me and give me the two decimal places.
So the two decimal places, right?
Pardon me?
To two decimal places,
Yes,
right?
it says the two decimal places, yes.
Sir, 5.27.
So 5.27, anybody else getting that?
Yes, sir.
Okay, good. So that's the length of the line there, PQ. All right. Now to tell us that R is a midpoint of PQ. Again, this question is about coordinate geometry. These things are coordinate geometry related topics, right? R is a midpoint of PQ. Determine the coordinates of R. So since I already have a general line here, where's my freezer this week? All right, so since we have a line segment here already, AB, the midpoint of the line, let's call it M. The midpoint M is given by x1 plus x2 over 2, comma, y1 plus y2 over 2. That is how we find the midpoint of a line. Is that clear?
Yes, sir.
Yes, sir.
So, going back down here, if P is the point 5, 0, and Q is the point 0, 5 thirds, find the midpoint of PQ. And do not put it as a decimal, leave it as a fraction. Go ahead and find the midpoint of PQ. We typically do not represent coordinates of points using decimals, but fractions, okay? So leave it as a fraction if it's not a whole number. So you add the x coordinates, divide by 2, add the y coordinates, divide by 2. That gives you the midpoint of the line. Found the midpoint.
Yes,
Again,
sir.
start with the small answer.
Huh?
I have to leave it as a fraction, sir.
Yes, leave it as a fraction, not a decimal. So it's 5 plus 0 over 2. Then you have 0 plus 5 over 3 over 2, which of course gives us 5 over 2, comma, 5 over 6. Did you get that?
Yes, sir.
Yes, sir.
So right, so R is the point, 5 over 2, 5 over 6. Right, next part. Part B deals with functions now. The functions f and g are defined as follows. F such that x is mapped onto 5 minus x. Now, this is just another way of representing functions. It is exactly the same thing as this. F of x is equal to 5 minus x. Likewise, this is read g such that x is mapped onto x squared minus 2x minus 1, but it simply can be written as g of x is equal to x squared minus 2x minus 1. Is that clear?
Yes, sir.
Yes, sir.
So whenever you see those, you could automatically rewrite them using that notation. F of x equals 5 minus x, g of x equals x squared minus 2x minus 1. Now, part B says, well, not part yet. The graphs of f of x and g of x meet at points m and n. Determine the coordinates of the points m and n. What are we really expected to do here? To find the coordinates of m and n. What are we expected to do? What is the name of the process? If we're told a line and a curve meet at 2 points and we want to find the coordinates of those points, what must we do? What is the name of that process to find those points?
And the
Great.
simultaneous equation.
That is it. So we have to solve these equations simultaneously, right? So look at the two equations. What type of functions are they? We have f of x equals 5 minus x, and we have g of x equals x squared minus 2x minus 1. Are they both straight lines?
No, sir.
Is any of them a straight line?
Yes, sir.
Which one?
So g of x.
Repeat that?
So g of x.
Absolutely not. G of x cannot be a straight line. It has an x
Oh,
squared
it's
term.
squares. Yeah.
That is a
Okay.
quadratic, so it's a curve. The straight line is 5 minus x. Okay?
Yes, sir.
Remember that straight line equations can't have any higher power than one of the particular variable. So if it's a function of x, cannot have x squared or x cubed. That would be a straight line. It's a curve. So one of these is a straight line, the other is a curve. And how do we normally solve simultaneous equation between a line and a curve? There's only one method we can use. What is the method? Which method?
Sure.
Huh? What is the method we use? Come on, man, it's not the first time I'm asking these type of questions. Earlier in the session, I asked about the two methods of solving simultaneous equations, and you told me them. So which of those two methods are we going to use here?
So elimination.
Huh?
Elimination.
No, man, we can't eliminate anything when dealing with two curves with a line and a curve. No. Elimination only applies to straight lines, typically. If we have two straight lines, we can eliminate one of the variables. But in any case, substitution is a method we typically use to solve simultaneous equation between a line and a curve. But in this particular case, essentially, we are given the two equations in the form y equals something. So basically, we can say that, well, y equals 5 minus x, and we also have y equals x squared minus 2x minus 1. To solve these, we simply equate the two right-hand sides, the x parts. And so we say that x squared minus 2x minus 1 is equal to 5 minus x. And I'm going to leave you to solve that. So bring all the terms to the left-hand side, simplify, and then solve the quadratic equation. You should be able to do that. All right? So take it from there. Bring all the terms to the left-hand side, simplify, and then solve the quadratic. It may or may not be able to be factorized, but check if it can be factorized. If it can't be factorized, you must use a quadratic formula. Okay?
Yes.
So go ahead and try that one. Remember, you're an examiner, so you have to do the practice. You finished?
One minute, sir.
Hello?
Yes,
Or should I
sir.
ask? Getting through? You getting through? Okay.
Yes, sir.
So let me know when I'm finished, okay?
I'm finished, sir.
All right. Amari?
Sir, I'm almost finished, sir.
Okay. Camelia?
Finish.
Okay.
Finished, sir.
All right. So with this one here, so as I said, we bring all the terms to one side, try to factorize first, and then solve and solve. So when you bring the terms over to the next side, we get x squared minus 2x minus 1 minus 5 plus x is equal to 0. And so we have x squared. The minus 2x plus x is going to give us minus x. And so we have that x squared minus x. And the minus 1 minus 5 gives us minus 6 equals 0. Can this be factorized? Are there any factors of negative 6 that add to give minus 1? The answer is yes. So the factors of negative 6 which add to give minus 1 and minus 3 and 2 and plus 2. So we get x squared minus 3x plus 2x minus 6 equals 0. So we have x bracket x minus 3 plus 2 x minus 3 equals 0. So we have x plus 2 times x minus 3 equals 0. So x plus 2 equals 0, which means x equals minus 2, or x minus 3 equals 0, which means x is equal to 3. Did you get those values?
Yes, sir.
All right, but the question asks us to find the coordinates of the points M and N. And so after we find the x coordinates, we have to find the corresponding y coordinates by substituting these x values into one of the two equations, typically the simpler one. So let's use the straight line. So say y is equal to 5 minus x. So when x is equal to negative 2, y is equal to 5 minus 2. is equal to 5 plus 2 is equal to 7. And when x is equal to 3, y is equal to 5, minus 3 is equal to 2. So therefore, the points of intersection are minus 2, 7, and 3, 2, right? Did you go ahead and find the y coordinates? Hello?
No, sir.
Yes, sir.
Well, you
Yes,
needed to have done that because it says determine the coordinates of the points M and N. Whenever you ask to find the coordinates of a point, it means both X and Y coordinates, all right? So don't make that mistake again. Good. All right, let's move on to part C now. Now, part C has to do with what we call a speed time graph. Does any of you do physics by chance?
I do, sir.
Oh,
Yes,
yes,
sir.
come on, you do physics. Renako, you do physics?
Yes, sir.
All right. What about you, Camelia?
no, sir.
Okay. Well, for those who do physics, you're supposed to be familiar, have some level of familiarity with speed time graphs. But anyways, so we say that Monty is cycling at 12 meters per second, right? So we can see that on the graph. That's between. So first of all, let's see what is on the graph. On the y-axis, we have speed in meters per second. That is the unit of speed there, meters per second. And we have time in seconds. So Monty is cycling at 12 meters per second, as you can see from the graph. So we see that there's a horizontal line, this line right here, and it continues there up until this value right here, which would be midway between 4 and 5. This is 4.5 seconds, okay? So Monte's speed is constant for 4.5 seconds. Subsequently, its speed decreases uniformly because it's a straight sloping line. So we say that it decelerates. So deceleration or to decelerate means to slow down, right? And when you slow down, that means the speed decreases, right? At this level, we're going to be dealing with a uniform decrease in speed or uniform deceleration, or in some cases, acceleration, right? So we're told that after 4.5 seconds, I just saw that actually, after 4.5 seconds, it starts to decelerate, and a further 2.5 seconds, after further 2.5 seconds, it stops. The speed time graph is shown below, right? So we could have actually inferred all that information straight from the graph without being told, but you were told, you're given the information. So calculate the constant deceleration. So let me call this point here A and this point B. So the constant deceleration is going to be the gradient of AB, but we just normally write the positive value. So the constant deceleration is basically equal to the gradient of AB, which of course is equal to the change in y over the change in x, or in this particular case, because speed is on the y-axis, then this of course is a change in speed v divided by the change in time t. Good? So at the point A, we can put in the coordinates. The time is 4.5, 12. So 4.5 represents the time in seconds, 12 is the speed in meters per second. And at B, of course, the value is 7, 0. Is that clear?
Yes, sir.
So let's find the gradient of AB. So the gradient of AB is equal to, we can say y2 minus y1 over x2 minus x1, which of course gives us 0 minus 12 over 7 minus 4.5. Sorry, is that 4.5? Yeah, 4.5, yes. So this gives us minus 12 divided by 2.5. So go to your calculator for me. What is minus 12 divided by 2.5?
I got negative 4.8, sir.
So negative 4.8. And the units, we must put our units. It is going to be meters per second squared. So therefore, we say that the constant deceleration, when we speak about deceleration, we just ignore the negative sign, but you can just say it. So this is 4.8 meters per second squared, okay?
Yes, sir.
So that is how we find deceleration or acceleration from a speed-time graph, the gradient of the graph. So for instance, for the first 4.5 seconds, where the speed is constant, the acceleration obviously is zero. When the body speed is constant, there's no acceleration, okay? Because speed is not changing. Is that clear?
Yes, sir.
All right. Now, part two, Monte's average speed over the 7 seconds. Now, when we speak about average speed, is not just from a distance time or from a speed time graph. Is not just to take different values of speeds and add them up and divide by the number of speeds. No. The average speed as from a distance time graph, this is the formula for average speed. The average speed is equal to the total distance traveled divided by the time taken. That is how you find average speed from a speed time graph. The total distance traveled over the time taken. But how do you find the total distance traveled? The total distance traveled is going to be equal to the area under the graph. Right? Now, what type of shape is this? Can anybody identify the shape?
Sir.
Come on, man, I expect you to be able to identify the shape. Nobody can identify the shape? It's a trapezium.
Yes.
So we're talking about here, the entire thing is this. That is a shape. So we can treat it as a trapezium, or we can split it up into a rectangle and a triangle. Let's call this region 1, region 2. So the total distance traveled So the total distance traveled is equal to the area under the graph, right? So we split it into regions. So let's just do it the region by region. So we can say the area of region 1. Now, region 1 has a base of 4.5 seconds. So from 0 to 4.5, that is a base of region 1, right? So 4.5. And of course, the height, of course, is 12. So the area of region 1 is going to be 4.5 times 12. It's rectangular, length by width. Region 2, what shape is that for region 2?
Triangle.
Triangle. What is the base of the triangle? We're going from 4.5 to 7. So what is the base?
2.5.
2.5. That is correct. So we're going to say plus 2.5. The height is also 12 times 12. And this is over 2 because it's a triangle. So 4.5 times 12, that is what? 54. This, of course, will be meters, not meters squared. Many students are prone that whenever they're calculating area, they're meters squared. No. we're talking about the area under a speed time graph. The area under a speed time graph gives distance traveled, typically in meters. This is 54 meters, not meters squared. And then this, of course, is 2.5 times 6, which is 15 meters. When we add those two, that gives us 69 meters. So the total distance traveled is 69 meters. Now, we could have also calculated the area using the trapezium formula. So using the area of the trapezium formula, the distance traveled, so the area A would be equal to the sum of the parallel side, let's just call it A plus B, times the separation divided by 2. So in this case, the parallel sides would be the base of the entire figure, which is 7, and the top part here up to A, which is would be 4.5. So 7 plus 4.5 times the separation between them, which of course is the speed, 12. And this is divided by 2. So 7 plus 4.5, that is 11.5. Is correct?
Yes, sir.
Yeah. Mm-hmm. Hold on. All right, so 11.5 times 12, what does that give us? 132 plus 6, 138. Yes, so this gives us 138 divided by 2, which of course gives us the same 69 meters, right? So this is using the trapezium formula, area, or the trapezium. We get the same answer. All right? So that is the total distance traveled. We're not finished because we need to find the average speed. So using this formula here, the same formula, we can say that the average speed would be equal to the total distance traveled, 69 meters, over the total time taken, 7 seconds, because the object was moving for 7 seconds. And so 69 divided by 7, 7 to 69 goes 7 times 9, that's 63. That's about 9 point, what is 6 divided by 7? About 9.8 something.
9.86, sir.
All right, so 9.86 meters per second. So that is the average speed for the entire journey. All right? And that's the end of the question there. So in these questions that we looked at so far, we're able to do some coordinate geometry involving the equation of a line, perpendicular lines, midpoint, and so on, length of the line. We did a little bit of functions, simultaneous equations, speed time graph. So we have covered a few different topics using these 3 questions. It is imperative that you do as many past paper questions as possible because you get practice and you also get exposed to the type of questions you like to be asked on the exam. So you're essentially killing 2 birds with 1 stone, right? So I would have done questions from January 2024, which was this one here. Well, no, the first one I did was January 2024. This one, I also would have done from June 2022, and I also would have done from, I think, is it this January? So June 2021. I had copied one more paper, but let me see if this is something you should be able to try. Yes, you should be able to do this one. This one is from, so it involves things like function, well, obviously functions again, composite functions and domain and things like that. So composite function, fg of x, inverse of a function, and a little area, a little figure here. So I want you to do this question and of course try to, well, not try, but attempt other questions from the more other years. So I would have stopped at 2021, I think. So from 2019, go back. You should be able to do a few question 8 from those papers, right? So between now and the next time that we meet, I want you to do at least four of those questions. And during the week, if you're having any trouble, you could always message me. I'll always try to respond, right? So yes, so do this one. This is from 2019. There are a lot of past papers in the Google Classroom. I will check to see if this one is actually there. But it should be, but I'll check, right? But if it's not, just do other questions from the other years going back, from 2018, go back, all right?
Sir,
Mm-hmm.
which years do you recommend going through?
I mean, as many as possible, but the most from the most recent ones working backwards. So I would have gone through the ones that I have, the most recent ones I have, 2024, 2022, 2021. I don't have 2023 people. And the next one I had was 2019. So the more recent ones, those are the most you should be working through. Start from the most recent ones and then work your way back. All right?
Uh, yes, sir.
If you can fully go through probably say 10 years of papers completely, then you should be okay for the exam. All right?
Yes, sir.